So in this video, we're going to go over how to solve rational equations that have more than one expression. So what we're going to do to solve this type of rational equation is we're going to first factor all of the denominators in the equation. Because what we're going to need to do is figure out the LCD of all the fractions on both sides of the equation. So this is going to be similar to what we did when we were adding and subtracting rational expressions. Then we're going to multiply both sides of the equation by the LCD, and this is going to allow us to get rid of all the fractions. So then we can simplify and then solve the resulting equation and check for extraneous solutions. So let's see what this looks like. So here, I'm going to think of all of these as fractions, right? So I'm going to put my 3 over 1. So I don't need to factor any denominator because all of these denominators are prime. So I'm going to figure out the LCD. And remember, in order to do that, I'm just going to take my one denominator, right? So I have my x minus 3. And then I'm going to pick up all the other factors that I have in the other denominators and I haven't written yet. So I need an x plus 1. Okay, and then this denominator is 1. If you want to, you can write a 1 in your LCD, but multiplying by 1 doesn't really make a difference, so I'm going to leave the 1 out. So what I'm going to do now is I'm going to take this LCD and I'm going to multiply every single term in this rational equation by this LCD, okay? And you'll see what happens when I do that. So I have x minus 3 times x plus 1, and like you can think about this as being over 1, right? So that's going to multiply x plus 2 over x minus 3. Okay, and then we go to the next term. Once again, I'm going to multiply x minus 3 times x plus 1. And let's just put that over 1. And I'm going to multiply that now by 6 over x plus 1. And then I need to multiply the right side also, right? Because remember, when I'm multiplying an equation by something, I have to multiply every single term by whatever it is that I'm multiplying by. So you see here, I've just taken this equation, okay? And then every single term, I've just multiplied by x minus 3 times x plus 1 over 1. Right? So you see this term is here, this term is here, and then on the right side of the equal sign, I have, once again, this x minus 3 times x plus 1. Okay, so what happens here now is I'm going to be able to clear out some of these fractions. That's the whole purpose of using this method. So you see here I have an x minus 3 that cancels. So my first term is just going to be x plus 1 times x plus 2. Now let's go to the next term. So I have an x plus 1 that will cancel right here and here. So I'm just going to be left with 6 times x minus 3. Now I go to the right. Well, here nothing cancels, but all I have left is a 3 times x minus 3 times x plus 1. Now I need to do a whole bunch of distributing and using FOIL to simplify everything, right? So if I do x plus 1 times x plus 2, and you all can FOIL this on your own, you're going to get x squared plus 3x plus 2, okay? And then we do plus, now we distribute the 6. Right? So we get 6x minus 18, and that's equal to, well, we have 3 times, I'm going to FOIL this before I multiply by 3. Okay, so when I FOIL it, I get x squared minus 2x minus 3. Well, when I multiply that by 3, I'm going to get 3x squared minus 6x minus 9. Now let's look at the left side. I'm going to look for my like terms, and I'm going to go ahead and combine them to simplify. So I have an x squared, right? So I'm just going to write x squared. And then I have plus, well, I have a 3x and a 6x, so that's going to combine to 9x. And then I have a 2 and a minus 18, so 2 minus 18 is going to give me minus 16. Well, if you look at this now, you'll notice that it is actually a quadratic, right? It's a quadratic because my highest degree term is a square term, so what I need to do is set this quadratic equal to 0 in order to be able to solve. So to do that, what I'm going to do is I'm going to subtract x squared, and I'm going to subtract 9x, and then I'm going to add 16 to both sides. Okay, so I'm going to go over here, minus x squared minus 9x plus 16. So let's go ahead and combine all these terms. So on the left side, everything's going to cancel out, and I just have 0. And then on the right side, I have 3x squared minus x squared, so that's going to be 2x squared. Minus 6x minus 9x, that's going to be minus 15x. Minus 9 plus 16, that's going to be plus 7. Okay, so I have 2x squared minus 15x plus 7. So now let's go ahead and solve this quadratic. I have 0 equals 2x squared minus 15x, and then plus 7. Okay, so there's lots of different ways you can solve this. Remember, this is A, this is B, and this is C. So we can use the A times C method, right? Let's try and factor it because I actually like to factor. So A times C is going to give us 14. So now we need 2 factors of 14 that are going to add up to negative 15. Since 14 is positive, we know the factors will have the same sign. So we're going to make them both negative because 15 is negative, right? Remember, B is going to decide the sign of all our terms. So we have 1 and 14 2 and 7. And if we make everything negative, notice that negative 1 and 14 are the only correct pair, right? That's going to add to negative 15. So I'm going to actually factor this by grouping, but if you have a different method you like to use, feel free to go ahead and do that. So I have 2x squared minus 1x minus 14x plus 7. I'm going to put my terms into two groups, right? And then so I'm going to factor out the GCF of each group. From the first group, I factor out an x. So I have 2x minus 1. And then plus the second group, I'm going to factor out a negative 7. Because remember, if the first term is negative, you just factor out that negative. And that leaves me with 2x minus 1. So this is going to be x minus 7 times 2x minus 1. And remember, that was equal to 0. So I'm going to set each of these factors equal to 0 and then solve for x. So when you go ahead and do that, you're going to get two solutions, x equals 7 and x equals 1/2. So now what we're going to do is we're going to plug in these solutions and make sure that they both work in our original equation. So if we plug in 7, we get 7 plus 2 over 7 minus 3 plus 6 over 7 plus 1 equals 3. So that's going to give us 7 plus 2, which is 9. 9 over 4 plus 6 over 8 is equal to 3. So if we go ahead and do that, we have 9 over 4 plus 3 over 4 is equal to 3, and that's 12 over 4, which is equal to 3, right? So that one does check. If we plug in 1/2, you will see that we also get that solution does work, okay? So both of these solutions, x equals 7 and x equals 1/2, are valid in this equation. So now let's try this example. So I wanted to go over this one because here the denominators are not all already factored for you. So what we need to do actually is notice that this x squared minus 6x plus 8 can be factored, okay? So when we do that, we get 2 over x minus 2 times x minus 4. And we say that's just minus 1 over x minus 4 because that one doesn't factor. And that's equal to x over x minus 2. So now we need to figure out the least common denominator. So the least common denominator, remember my strategy is to write down all the factors from one denominator. And so let's go ahead and do that. So we have x minus 2 times x minus 4. And then I'm going to add in any factors from the other denominators I have not already written down. Well, I already have an x minus 4, so I don't need to write it again. I already have an x minus 2, so I don't need to write that again. So what I'm going to do now is multiply every single term in this equation by x minus 2 times x minus 4. And I'm just going to go ahead and put it over 1. And so that's 2 over x minus 2 times x minus 4. And then minus, and then we have here, we're going to multiply x minus 2 times x minus 4 over 1. And then that's going to multiply the 1 over x minus 4. And that's equal to, here we have x minus 2, x minus 4. And then multiply that by x over x minus 2. So what we're going to do now is we're going to cancel common factors, okay? So we cancel common factors and we cancel x minus 2, x minus 2. We cancel x minus 4, x minus 4. And so we have 2 minus, and then here what's going to cancel is the x minus 4. And so then we have x minus 2. And then that's equal to, on the right side, the x minus 2 and x minus 2 cancel. And then we have x times x minus 4. Okay, so now we just need to simplify, distribute, combine like terms, all of that equation solving, right? So here we distribute this negative, so we have 2 minus x plus 2, and that's equal to, here we distribute this x, and we have x squared minus 4x. Okay, so now on the left side, I'm going to combine like terms, so I have 4 minus x, right, because I put this 2 and 2 together, and then on the right side, I have x squared minus 4x. So notice that this is now a quadratic, right? So remember when we solve quadratics, we go ahead and set it equal to 0. So I'm going to subtract 4 and add x to both sides. And remember when I do that, I'm going to make sure and combine like terms together. So when I do that, I now get the new quadratic equation, 0 equals x squared minus 3x minus 4. So here, if I solve 0 equals x squared, let's see, I had minus 3x minus 4. I like to solve by factoring. So remember, we need two factors of negative 4. So that's going to be a positive and a negative. Since my b is negative, I'm going to make my bigger factor negative. So the factor pair that works is actually going to end up being 1 and negative 4, right? That's going to give me negative 3. So if I go ahead and factor this, I get x plus 1 and then x minus 4. If I set my two factors equal to 0 and solve for x, I'm going to get two values of x, which are x equals 4, x equals negative 1. Well, remember, since I'm solving a rational equation, I need to go back and check and make sure I don't have extraneous solutions. And I'll give you all a hint. The best way to check for extraneous solutions is to see if any of your values make your denominator 0. So if you think about it, an x value of 2 and an x value of 4 would make denominator 0, right? So that's why this x equals 4 is actually an extraneous solution. That's like a quick way to do it. If you want, you can plug them both in, but you can see that x equals 4 is extraneous, so x equals -1 is the only solution to this problem. You can go ahead and pause the video and try doing this example on your own. So here what we do to figure out the least common denominator is we'll put this x over 1. So the only really term we have in the denominator is this x plus 2. So I just multiplied the entire equation by x plus 2. So that gave me this equation, which did turn into a quadratic. I set it equal to 0, so I got x squared minus 2x minus 8 equals 0. Once again, I solved by factoring, and so that gave me x minus 4 times x plus 2 equals 0. Here you can see what I did is I plugged in 4, and that did work correctly. -2 is an extraneous solution because you can see if I plug in -2, it's going to make these denominators 0, right? So that's actually not going to be included. That's an extraneous solution.